G'day folks, this is the very last lesson of new content for the preliminary course. And it is relatively new content, although a little bit old as well at the same time. This was content that's been added as a result of the changes in November last year. However, it was content that was in general maths, the course before standard maths, so they've just added it back in. So it's something that we're certainly used to having in the past, but it's now made its way back in. So this relates to our unit we did on data late last year. So that was when we were doing the unit where we were doing histograms and Pareto charts. And you might remember at the very start of that topic, lesson 2 dealt with the methods of sampling, and there was random sampling, there was systematic sampling, there was stratified sampling, and there was self-selected sampling. And this sort of loosely relates to that area. It's called capture, recapture. So I've sort of called it lesson 2B sort of because it should sort of follow after that one. And basically this is a situation where if we use random sampling, we can estimate the size of a population. So obviously we talked a lot during that particular course about, taking a sample of kids at school and taking a sample of all manners of things. But sometimes we don't actually know what the population is. So the example here is given as fish in a lake. We don't actually know for sure how many fish are in the lake. So what we can do is use the capture and recapture technique. So we capture a random sample, we tag all of that sample. They're then released back into the environment so they can intermingle in. And then we capture another batch and we look at how many of the ones we captured this time were the ones that we tagged last time. So there's a nice little diagram of it here. We want to estimate the fish in the pond below. First we'll capture some, so there's 15 there that get tagged, then we'll release them back so they can mingle with the others. So the red fish that we've tagged, they've all mingled in with the others, and then we'll catch another sample, and this time we've caught 2 fish that we'd already caught once before. And so we can then use this formula where we just say, well, look, the number we tagged, the number that are tagged in our sample divided by the total number of our sample must be the same, or we assume it's going to be the same as the number that are tagged in the population divided by the total population. So we know when we sort of look at this, well, we know that, and we know that because that's the second sample we grab. We know how many are tagged in that sample, and we know how many are in the sample, and we know how many are tagged in the population because we've tagged every fish that's in the population that's been tagged, we tagged, so we know what that number is. So once we know 3 things out of 4, we'll be able to work out the final thing. So probably the easiest way is to sort of see that done. So here we've got in a reserve 50 deer were captured, tagged and released. And a few weeks later, 40 deer were captured and 8 were found to be tagged. So that proportion of the tagged ones as a proportion of the second lot we grabbed has to be equal to, or we assume it's equal to, the number that were tagged initially divided by the whole population. So we just use that basic premise. So in this particular case, we can use a bit of algebra. Now you'll get used to how this works out, but if we multiply both sides by the population, we're going to have 8 times by 40 times by the population equals 50, and if we multiply both sides by 40 on 8, then this is going to cancel out here. That 8 and that 8 are going to cancel out. That 40 and that 40 are going to cancel out. So I'm going to be just left with the population on that side. So I'll have to multiply this side by 40 on 8. Now you might see that it always works out the same sort of way. So you can probably just make yourself your own shortcut there. But our population is just going to equal 50 times by 40 on 8. Or we could have also just worked out that 40 on 8 is 5, but yeah, it doesn't really matter there. So 50 times by 40 over 8 equals 250. So we assume there must be 250 deer based on our tagging. Now, sometimes the number tagged in the sample will be just given as a fraction or as a percentage. So obviously we can just 3/4 means 3 out of 4 tags. So if we have a fraction, I mean, essentially that's what we had there. We had a fraction, so we can just put the fraction there, it'll be fine. And if we have a percentage, we can just make a fraction where that's represented out of 100. So 4% is 4 out of 100, 3% is 3 out of 100, and so on. So we've got a large dam, 60 trout were captured, tagged and released. A few weeks later, the number of trout were captured and 2% were found to be tagged. So 2 out of every 100 trout that we found were tagged. And we know that 60 were initially tagged out of the whole population. Okay, so we can, once again, we'll multiply both sides by the population. So population times by 2 over 100 equals 60. And then we multiply both sides by the reciprocal of 2 over 100. So that's going to be 100 over 2. Now, obviously, you might be able to see that 100 over 2 is 50. So 60 times by 50, you can put that into your calculator if you want to, or you can know that it's just going to be 3,000. And there we go, 3,000, because 6 5s are 30 plus the 2 zeros, so we're going to end up with 3,000. So we've got our estimated population of trout in the dam. And the final example we'll have here is some zebras in a wildlife reserve. So 30 were captured, tagged and released. A few weeks later, some more were captured and 5% were found to be tagged. Let's do this one a little bit differently. Let's just represent 5% like this. So 5% equals 30 divided by the population. So if we leave 5% there and times it by the population, that's going to equal 30. And we could divide both sides by 5% now. So the population equals 30 divided by 5%. Now, we could sort of represent that as 30 divided by 0.05. Either way is going to work. If we use our calculator, 30 divided by, and I'll do 5% on this occasion. Where's the percent button? Right there. And we're going to end up with 600. Right, so that's another way of doing it. If we've got a percentage there, we can just leave it as a percentage. And that might be a little bit easier to understand than multiplying by reciprocals, whatever works for you. So that's the end of that particular idea. There's some great little examples there in exercise 11b, which is not in your textbook. Don't go looking in your textbook. In the theory book that I put on Classroom for this, it's on there. And also in OneNote, that particular section of the textbook. It's the old general maths textbook that was used before last year. So have a crack at the questions in there. You'll find that they're not too bad to have a go at. And that brings us to the end of all of the new content for prelim. From here on in, we're getting some revision done and getting ourselves ready for the HSC course to start next term. Thanks.